guys, how are you all? And in this video I'll be talking about the seismic weight of the building. Okay, so seismic weight of the building is nothing but the total sum of the dead load and the live load that is imposed on that building. Alright, so for calculating the seismic weight, you have to first calculate dead load and then the live load, and if you sum these two, you'll get the seismic weight of that building. Alright, so dead load calculation. Okay, so you can do dead load calculation by different methods, and here is my approach. Okay, what you do is that you first calculate the area of each component. Each component means that any beam, column or wall, whatever you like. So area is basically length into breadth. Okay, so you multiply the area of that component into its height to get the volume. So volume is equal to area into height of that component. So dead weight of the component is equal to unit weight times this volume. Alright, so unit weight you can get from IS 875 part 1 of any material you like. Alright, so live load is area of the slab into live load intensity. Alright, so you can get live load intensity from IS 875 part 2. Alright, so here this is how you calculate the dead load, and this is how you calculate the live load. If you sum these two, you get the seismic weight. Okay, so for demonstrating the seismic weight calculation, I have taken an example. Okay, alright, I'll be using this building. So here is the section of that building. It has got basement, then semi basement, ground floor, first floor, and rest of the floors. Okay, alright. Okay, so seismic weight of the building, let me see. Alright, here it goes. Okay, so seismic weight of the building, the rule says that for calculating the seismic weight of the building, you don't have to consider the portion of the building that is below the earth. This is your contour line. This this line shown in the diagram. So this is your contour line, and this portion is below the earth. Alright, so you don't have to consider a weight of this portion while calculating the seismic weight of the building. Okay, so you only have to consider the portion of the building that is above this line or above the earth. Alright, so okay, so while calculating the seismic weight of the building, what we do is we take, so here is the ortho mode. Oh, this is not at half. Right, okay, so somewhere here. Okay, so what we do is we take half portion of okay, so this is your same basement floor, and this is your ground floor level, and this is your first floor, right? So this is your floor and this is your another floor. Okay, so this is your ground floor level. So one floor, another floor, and ground floor level. Only focus on this region. Alright, okay, so what we do is that we take half of this portion. That means the half of the columns and half of the walls and all the beams and the slab. Alright, so we calculate the weight of all the columns, beams and slab, and take the height of the column and wall as half. Alright, same goes for this floor. We take half of the height of the columns, walls, and now we have already taken slab and the beam. Alright, so we got some weight here, we got some weight here, half weight here, half weight here, right? So we add these two. So for example, if the weight is A here, weight is B here, we do A plus B. Alright, so A plus B. If it is C, we lump or concentrate that weight in this floor. Alright, so that weight is the seismic weight of ground floor. Alright, so we take the weight of this half portion or of this floor and half portion of this floor, we add these two, and concentrate that weight in this floor that is on the ground floor level, and it becomes the seismic weight of the ground floor. Alright, so here you this is the basic concept of the seismic weight. This is also known as the lump mass, because we lump the entire mass in one floor or in one region. Okay, alright, so okay, so I have taken the example of this ground floor, and this is how you do. First you calculate the area of each portion, as I've already said. So this is the dead load calculation. Okay, so area of main slab. Alright, so let me show you here. So this is our ground floor plan. We have got a main slab here and some cantilever right over here, 4 feet 6 inch passes. Alright, so some cantilever over here also. Alright, so we calculate the area of the main slab. Alright, so area of the main slab, then also the cantilever slab. So you can do you can calculate the area of the slab using different methods. For example, if you want the area of this slab region, what you can do is that you can just take your length from here to here. Alright, it's 20 feet and 6 inches. Again, what you can do, you can take your length from here to here, leaving the beams. Alright, from here to here, so it's 20 feet 9 inches. So you multiply 20 feet 6 inches with 20 feet 9 inches and you get your area of this slab. Same you can do for this panel, this panel, this panel, and you add all the area of all the panels and you get the total area of this slab. Or what you can do in AutoCAD, that you can just hit area command by typing AA. Alright, and you can begin from here. Okay, so you go all the way all the way to this and this portion, and you can just go on including every area. So I'm going a bit rough, but you should do it in a fair way. Okay, so I don't want to make this video very long. Alright, so there is a hysteresis void over here and the lift void, and here we go. Hit enter. So this is your area, so 633399.179 square feet. So this is your area. Alright, so you have to subtract the columns here and also the beams. Alright, so if you do that, you'll get the area of the main slab, and same goes for the cantilever slab. So after that, area of the beam. So along alphabetic grid, that means that we got 2 grids. So this is the numeric grid. Alright, so this is the alphabetic grid, A, B, C, D. So along alphabetic grid, alright, so and along numeric grid, so we got two kinds of beam. One is major beam and another is secondary beam. So for major beam, so there are 60 number of major beams along alphabetic grid. So there is a 1 2 3 1 2 3 4 5 6. So you go adding up and you'll get 16 as your number. So 16 times 6.553, that is length of this beam from here to here, right? So from here to here, so you can calculate the length like this. Alright, so it's 19 feet and 6 inches. Alright, so so that is 6.553 meter times 0.380, that is the depth. Alright, so I think I have taken it as the center to center, from center of this column to center of this column. So you shouldn't do it. So you have to do is that you have to take from this face of the column to this face of this column. Alright, okay. Okay, so after that, secondary beam, we don't have any secondary beam in this alphabetic grid. Okay, so along numeric grid, that is along this grid, this 1 2 3 4 5 along this grid. Alright, so we have where is our major beam. So major beam, we have got 4 number of beams that has length 6.248, 4 number of beams that has length 6.401. Then goes for other beams, right? So you calculate the area of all these beams, all this beam, this beam, this beam, this, and every beam that you encounter in along alphabetic grid. Alright, so you calculate the area. So area is length times the depth. Alright, so length times the width. Alright, this is your area. So, okay, so area of the column. So area of the column, so we got 23 number of columns. So this is your column 1, column 2, 3, 4, 5, 6. So you add all these columns and it's 23 times 0.5 times 0.5, it means that, so 0.5 is length and 0.5 is width, that is 500 mm. Okay, alright, so area of the outer wall, so that is the outer wall I have taken as the prefab wall. So you can also use the outer wall as the brick wall. So this is your outer wall. So this is your wall. You got a wall over here, so you got a wall over here, right? So over here, here. So this is your outer wall along this outer line. Alright, so along this outer line you got your outer wall. So oops, okay, Okay, so your total length times the thickness. Alright, so you can calculate the length by adding this and this. Alright, so this, so you just add up by taking the dimension. You can take the dimension as this. I have already shown you earlier. You can take the dimension, right? So you can go here, and it's 18 feet and 6 inches. So that is your length. So you can calculate that length times 0. So you got 3 same kind of 5.944 meter. So 2, you add the total length, alright, times the thickness. So thickness of this prefab wall is 0.075 mm. So that I have used 75 mm outer wall prefab, but if you are using a brick wall, it may be 230 mm. Alright, so that is 9 inches. Okay, so you get your area as 3.43423 meters square. So after deduction 30 sorry, so area after 30% deduction for openings, so it's so here you have got openings like window, and door. Alright, so you have to deduct this area because you don't have any brick or any prefab in this region, right? So you have to deduct it. So for deducting, so we take 30% for openings. So we deduct 30% for openings. So after deduction for 30%, we get so it's 3.423 times 0.7. So we get 2.396. Alright, so shear wall, same goes for the shear wall. You know, if we have a shear wall, I think we have got shear wall over here. So this region we have got the shear wall, right? So here, so here we got the shear wall. Alright, so we have to calculate the area. So total length, we add the total length of the shear wall times the thickness. So thickness of the shear wall is 230 mm, so that is 9 inches. Alright, so you can take the length of the shear wall, same as the earlier mentioned process. Take length from here to here, 19 feet 6 inches for this portion. Same you can do from here for this, and add all the length. Alright, so we deduct 30% for the openings, and we get the area of the shear wall as 3.934 meters square. Alright, so load calculation. Okay, so load due to the partition wall. So this is our slab, right? So this is our slab. So we got a partition here. As you can see, this is your partition, this is also your partition here. So that goes on the slab. Alright, so this is your partition. So yeah, okay, so that is load due to partition wall. That is the dead load. Alright, so it's not the live load, it's the dead load. So load intensity into the slab area. The slab area is 402.202 meters square. So I have already shown you earlier. So it's 40.202 meters square, right? So times the load intensity. So for prefab, the load intensity is 0.4244 kilonewton per meter square. But if you are using a brick wall, it might be 20 kilonewton per meter square or 19.2 kilonewton per meter square, depending upon the kind of the brick you are using. So you can get those loads in IS 875 part 1. Alright, the load intensity. So load due to the floor finishing is load intensity times the slab areas, and the load intensity is 1 kilonewton per meter square for the floor finishing times 402.202. that is our slab area. Alright, so we get it as 402.202 kilonewton. Okay, so dead load calculation, we have already calculated this area of the slab, beams and columns, right? So now we have to multiply it with the height to get the volume. Okay, so the main slab, we have the area as 402.202 meters square, and the height of the slab or the thickness of the slab is 130 mm, that is 0.13 meters. So we multiply 402.202 times 0.13, we get it volume as 452.286 meter cube. The unit weight of the slab is made up of concrete, so unit weight of concrete is 25 kN per meter cube. So we multiply 25 times 52.286, we get load of the main slab as 1314.343 kilonewton. Same goes for the cantilever slab. Alright, so beam in the alphabetic grid, major and secondary. So we got area as 39.842 earlier, as I have shown you earlier, and height. So this is the depth of the beam. Alright, so volume, unit weight, and the load. Okay, so say, and for the column, so 5.75 is that the area of the column times the height. So 3.223 is the height of the column. So height of the column you can get from this half. So height of the column, what you have to do is that you have to take half of this floor and add these two. Alright, suppose this is 10 feet and this is 10 feet, so this 5 feet, and from here comes 5 feet, 5 feet, 5 feet, it's 10 feet. Alright, so this is how you get the height. Okay, so here it is, where is, okay, so 3.223 meters. So area into height is the volume, volume into unit weight we got is the total dead load. Alright, outer wall we got as prefab, the area is 2.396 times the what is this height. Okay, so height of the wall, so height of the wall is same as that of the column. You have to, alright, so while taking the height of this column, you have to subtract, if you subtract the thickness of the slab. Okay, so same goes for this wall, you have to subtract the thickness of the beam, because we normally build our wall. So you got a beam here, right? So you got your slab just below the beam, so you have to subtract the depth of the beam. So floor to floor height minus depth of the beam you have to do. Okay, so for same goes for the shear wall, and the partition wall we have already calculated, and floor finishing we already have calculated. So staircase and lift, you can calculate the dead load of staircase and lift, following same volume into unit weight formula. So staircase we have to calculate the total dead load of all the tree, riser and waste slab, and the landing. Lift is all the shear wall that you have got. Alright, so after calculating the dead load, you add up all the load all of all the components here. It's like this. Okay, so after that you go to live load calculation. So live load okay, so IS 875 part 2 has given live load for different kind of buildings, and in every building different kind of purpose, different kind of rooms for the different kind of purpose that the room has been used. It means that for example, this is our ground floor. So this is the educational building, right? So for educational building you have got different kinds of loads. So for in educational building, we have got as classroom, we have got faculty court or faculty staff's room for that, and we have got the lobby here, we have got a computer lab, right? So we have got a library over here. This floor has been used for different purposes. So live intensity changes according to the purpose that this floor has been used, or floor or the room has been used. Okay, so for classroom, the area is 174.475. You can get the area from the CAD, as I have already shown you earlier. So load intensity is 3 kN per meter square. So the load is, so this times this area times load intensity, we get is 523.426. So reduced load. So here comes the twist, right? Okay, so here is 1893 part 1 code. So it says that if the load intensity is up to and including 3 kN per meter square, so the imposed load is 25%. Okay, so if it is above 3, so imposed load is 50%. So here our load intensity is 3 kN per meter square. So the imposed load is 25% of this value, that is 130.856 kN. Alright, okay, so and here the load intensity is 6 kN per meter square, that is above 3 kN per meter square. So the load intensity is 50% of this value, that is this value. Okay, so did you get it? Alright, so I hope you can understand this. Alright, okay, so after that you add this value and you get 555.163 as your live load. So live load is this 1566.213, and the live load for seismic weight is this value. Alright, so if it's 3 and up to 3, if it's below and up to 3, it's 25%, and if it's above 3 the load intensity, then we take 50%. Alright, so total seismic weight of the ground floor is dead load plus live load. So live load is this value and dead load is this value, so you add these two, you get the total seismic weight of the ground floor. Alright, so we calculated the seismic weight for the ground floor. Alright, for this floor we took half, we lumped into the ground floor, right? Okay, so same goes for the first floor. You take half and lump the floor mass into this floor, that is in the first floor. Same goes for the second floor, half and lump it here. Same goes for the third floor, fourth floor here, the fourth floor, and for the top floor this only half portion, right? So there is nothing here, but there is something here. Alright, so for this open terrace only this half portion, right? Okay, and for the top floor, this is not at the center, but roughly, and this half only. Alright, so this portion, plus this portion for this one, and for this, this staircase cover, only this portion, right? Okay, so this is how you calculate the seismic weight of a building, and you add up all the weight, and that is total seismic weight of the building, of every floor. You calculate the seismic weight of different floors and you add them up and you get the total seismic weight of the building. Alright, so this is how you do it, and this is it for this video. Hope it was helpful, and if it was, hit like and subscribe for more some videos. Thank you.